Alright, so we are going to finish up the last little bit of our 4.5 notes here. This is kind of going the opposite direction of what we were doing. So this is writing a polynomial given the solutions. So we are going backwards from what we just did. So instead of finding the solutions, I'm given the solutions and I want to write that original polynomial. So let's look at an example. Say I'm given that my solutions are -1, 2, and 4. So if I'm given that those are my solutions, at some point I ended up with x equals -1, x equals 2, and x equals 4. So what I want to do is turn those back into the factors. So the factors would be when they are equal to 0. So this one would be x plus 1. This one would be x minus 2 and x minus 4. So once I get to this point and I've turned my solutions into factors, I'm just doing all of that multiplying. So I'm going to look at my first two binomials here and I'm going to do that distributing. So x times x is x squared minus 2x plus x minus 2. Then I have that x minus 4 that comes down. I'm going to simplify my first set of parentheses. And then I have all of this distributing to do here as well. So x squared gets multiplied by both. Negative x gets multiplied by both. Negative 2 also gets multiplied by both. From there, then, I just want to combine any like terms that I might have. So x to the third, negative 5x squared, plus 2x plus 8. And that would be my final polynomial. All right, let's look at another one. So my solutions this time are -2 and the square root of 3. So the deal is, anytime you end up with something in a radical, that's only part of the solutions. I know that there's no way I could get a solution of radical 3 without getting a solution of negative radical 3. And the reason for that is, kind of off to the side, think about, I would have had to come up with x squared plus 3 equals 0 somewhere, or x squared minus 3, sorry. So I would have x squared equals 3, or x equals plus or minus radical 3. So there's no way to get that radical without having the positive and negative version of it there. So if they give you just one radical, you have to know that you have the opposite of that as well. So I was only given radical 3, so my other solution, there has to be a negative radical 3 in there somewhere. All right, so from there, we're going to set up our factors. So if I get a solution of -2, I must have x plus 2 somewhere, x minus radical 3, and x plus radical 3. All right, so the same idea that we're going to do our distributing, and I'm actually going to hold off on the x plus 2. Anytime you have those two radicals, I want to do those together because I'm going to get some things that cancel out. So x times x is x squared. X times radical 3 is x radical 3. Negative radical 3 times x is negative x radical 3. Negative radical 3 times positive radical 3 is -3. So what's nice, in the middle, those end up canceling, and I have x plus 2 times x squared minus 3. So then I can do that distributing. So I have x to the third minus 3x plus 2x squared minus 6. So there's nothing to combine there, but I'm going to go ahead and write that in standard form. And that would be my final polynomial. So if I were to factor and solve that polynomial, I would get those same solutions. All right, we'll just try one more here. So this time, my solutions are -4, 3, and negative radical 5. So the deal is, they only give me negative radical 5, so I have to know that positive radical 5 is also a solution. And this time I'm going to have 4 sets of parentheses. So x plus 4 and x minus 3, x plus radical 5, and and x minus radical 5. So the deal is when I have 4, I'm going to do 2 together at a time. So I'm going to do these first two. I have x squared minus 3x plus 4x minus 12. And at the same time, I'm going to do these two together. So I'm keeping those radicals together. Alright, so now I can simplify each set. Let's cancel. Alright, so from this point, then all my radicals are gone and I'm just distributing. So I would have x to the 4th minus 5x squared plus x to the 3rd minus 5x minus 12x squared plus 60. And then I want to combine my like terms. So I have x to the 4th plus x to the 3rd. For x squared, I have negative 5x squared and negative 12x squared. So that's negative 17x squared. I just have my minus 5x, and only constant is 60. So again, if I were to factor this and solve completely, I would end up with x equals negative 4, x equals 3, and x equals plus or minus radical 5. So we're just going backwards from what we originally